very sharp meters. And what we're going to do in the Netherlands is open up the locks that are in this dam and let back a part of the tide that we've kept out for the last 40 years. The benefit of this is that it will bring back fish migration such as salmon. The bad thing about it is that it also brings back salt, which is in this case a bit harmful for agriculture, for industry and for drinking water. And this image will show very nicely what the idea actually is. This transition from salt to fresh should not be there in the dam, it should not be in the lake, but we want to have it on the ocean. We want to bring it out 20 kilometers as far as we can and make this transition from salt to fresh water as big as possible. So this estuary that we're creating is actually the mixing zone that instead of having salt water will bring us brackish water. Now, the benefit of this is that when you create a barrier island like this in an estuary, is that estuaries are incredible places when it comes to natural diversity, when it comes to nature development. We can really see that we can significantly increase the amount of nature, especially for species that really thrive in these brackish zones. And therefore we really try to design the island in such a way that we make as many transitions from dry to wet, from salt to fresh as possible to really stimulate the growth of this rare nature. And one of the main problems with this idea was always considered the stability. That if you put an island in the sea, it will simply wash away. We're making use of the very unique dynamic character of this area, as been shown in a lot of research. Actually, a lot of sand is being imported by the sea, by the currents, by the tide into this area. And we really believe that we can build a natural, sustainable shape following this coastal arc here that will form in a natural way by itself 200 years. And we're making this stable shape. That means that if you look at this side here, this very shallow area, you can build this island for a rough estimated 31 million euro. And that means that also a solution like this, making roughly 50 square kilometers of nature, will be able to reduce salt intrusion also for the next 50 or 100 years. And compared to the cost we have for coastal maintenance, for other innovative sound ideas, this is actually not so much. And we've also shown in our report that there are many ways that we can really benefit recreation, and that other areas in the world might also apply for this idea. And this will bring you to the conclusion of this idea. We are trying to solve the problem with salt using sand. And we're going to do this by making something that is actually 40 kilometers away from where the problem occurs. If you're interested in this idea or any of the others, please check out the website or any of the posters here, or join us afterwards. Thank you very much.
Sander, Emil and Bart, thank you very much for this contribution. We continue to number 3, which comes from the United States. It is Brian Whipple and Richard Fisher talking about thriving deltas. You are the tallest person who is speaking here, so please take care of the microphone.
Good afternoon. My name is Richard and this is Ryan. Today we will be discussing an opportunity for thriving deltas with an adaptive approach.
Deltas are pinnacles of life. They support environmental wealth through biodiversity, human populations, and industrial and agricultural production. Our project site, Sherman Island, is a critical geographic feature in the balance of saltwater and freshwater in the Sacramento-San Joaquin River Delta system located in California.
Water diversion for agriculture began in the late 19th century, and levees were constructed based on a static system where the land was at sea level, the soil was fertile, and the water was plentiful. Unfortunately, this is a dynamic system, and therefore, like many deltas throughout the globe, It was not designed to adapt to the challenges that we face today.
Unsustainable ecosystem management has led to the deterioration of the ecosystem, levees, and agriculture. Furthermore, agricultural practices have exposed the peat layer, resulting in subsidence at a rate of approximately 7.5 centimeters per year. This is equated to regions being as low as 7.5 meters below sea level.
Additionally, freshwater diversion to support the needs of 2/3 of California's population, or 23 million people, has wreaked havoc on this region, its ecosystem, by pushing the saltwater-freshwater boundary further into the delta. Additionally, global climate change as well as sea level rise has further exacerbated these issues, and it also places enormous stress on the decaying levee system.
So what does that all mean? This means that there is a 2% probability each year of catastrophic failure to the entire California region. This is because the levees in the region are built below a 50-year floodplain. In other words, 23 million people could lose access to fresh water in an instant. So, is this the future that we want?
I personally say no. So let's instead imagine an adaptive future. Now, what does that look like? Well, adaptation is the key to resilient and sustainable systems. Look at evolution, for instance. Now, we begin by addressing the worst first, which is levee instability. How do we do this? Well, we enclose a region at the westmost point of the island of approximately 324 hectares. Within this region, we backfoot it to about 1 meter. Immediately, this reduces the pressure differential on the levees currently. Now, the system involves a dynamic engineering approach. So as water level rises in the rivers and in the sea, we can siphon water into the system, thus dynamically stabilizing the levees.
So when we backflood into these interior regions, we stop subsidence. But if we take that a step further and say install wetlands into the region, you not only stop subsidence, but you reverse it by restoring that peat layer. And recent studies have shown that restoration to be between 4.1 centimeters per year and 7.5 centimeters per year. So now that we've talked a little bit about the ecological and safety issues, what about the social and economic ones?
Well, to address multiple stakeholder inputs, we need to address the economy as well as the social aspects, not just the environmental. We do this through allowing for an adaptive foundation where we can incorporate multiple options throughout time. One such option is the incorporation of soil as agriculture. We have designed this such that it can float within the flood storage zone. This allows us to revive the agricultural productivity of the region while letting it adapt to the changing water levels. Additionally, this can further be integrated with aquaculture in a system called aquaponics. This allows for either fresh fish production for sale, or we can revive some of the endangered fish species within the region.
There are a number of other economic options that are available. For instance, wetland-based carbon sequestration, floating community development, and floating energy production.
Therefore, this system provides the opportunity for environmental benefits, such as reviving the ecosystem, as well as rebuilding the peat layer in order to stabilize this levee system.
Economically, this provides a number of different revenue options available to the region to bolster the local as well as state economy.
And socially and culturally, this allows us the opportunity to bring the region back to its rich agrarian history.
So it's our hope with this project that the long-term vision is to create an integral link between the issues that are faced today and the issues of long-term sustainability, not only for the Sacramento, San Joaquin Delta region, but for Delta regions throughout the world.
Thank you.
Thank you very much, Richard and Ryan. I heard technicians and engineers and architects. I hope we could also hear some vision, as Professor Luis Fresco was inviting us to this afternoon. I was very impressed, but that's not so important. The real importance is to what extent the jury was impressed. I'd like to give the floor to the chair of the jury, Mrs. Tineke Huizinga, to tell us the jury report. Please.